Hello students. In the last video we have discussed about grammar notations and derivations. Of course, we'll revise this derivation once again here. So we have just completed the leftmost derivation. So we'll discuss the quick revision of the rightmost derivation also. And the parse trees. See, how can you say that? See, every grammar is going to accept some string. Like, see, for example, let me take the same grammar whatever we have taken earlier. E tends to E plus E or E star E or I. Then I tends to A. So first of all, identify the terminals and non-terminals. That is very much important here. See, the side is defining the left hand, I mean say that non-terminals and terminals. So the non-terminals and E and I, the terminals are only A, plus and star. And what are the productions we are having? Total 4 productions. E tends to E plus E, E tends to E star E, E tends to I, and I tends to A. And what is the starting symbol here? E. So every grammar is going to generate some language. So the language generated by the grammar is nothing but the set of strings accepted by the grammar. Then how to identify the string? A string is said to be accepted by the grammar if it should start from the starting symbol, and after applying any number of productions, then we should get that string. And the string is only in terms of the terminals. Means it should be in terms of A plus and star, nothing more than that, only in terms of terminals. Then how to derive a string here? See, there are two ways to derive a string. One is derivation and another one is parse tree. In the derivation we have again leftmost derivation and rightmost derivation. In the parse tree again we have top down parsing and bottom up parsing. So this we'll discuss in the compiler design subject, in the next semester subject. We'll discuss more about that. So in this video we'll just concentrate on the parse trees, not the types, and of course derivations. Then we have discussed about the leftmost derivation, how to go with the rightmost derivation. For example, I want to derive a string like same string whatever we have taken, A plus A star A. So whenever you are asked to derive a string from a grammar, always you have to start from the starting symbol. So E, right, derives. The single line arrow is production, the double line arrow is derivation. Now to get this A plus A star A, what I should substitute here? I need E plus E and E star E. That's your wish. What do you want to substitute? Let me go with the E plus E. The first, I'm replacing this E with the E plus E. You cannot substitute directly A star A plus A star A because we don't have such production. Then you can take it. You have to take the productions which you have already in the grammar. Then we got already plus, right? And we have before plus A and after plus A star A. But what is the rightmost non-terminal here? E, right? Then you have to go with the E. So to get this A star A, what I have to substitute for this E? You have to take E star E. Then let me go with this E plus E star E. So this E is replaced with the E star E by using the production called E star E. After two derivations, we got this. Same way we got plus and star. And what is the rightmost non-terminal here? E. So after star we are expecting A. Then you can take E plus E star. We are expecting A, but you cannot substitute E tends to A because we don't have such production. Then you take I. I. What is the production we have used here? E tends to I. Same, what is the rightmost non-terminal? I. Then you can go with this E plus E star A. I tends to A. Same way, what is the rightmost non-terminal? E. Then you can take it. E plus I star A. What is the production we have used here? I. Then same way, E plus A star A. Then we got I tends to A, like that. In each and every step, we are replacing the rightmost non-terminal. That is called rightmost derivation. If you are replacing leftmost non-terminal, then we can call it as rightmost derivation. That's the only difference, guys. Nothing more than that, right? So this is rightmost derivation. For the same string, we have taken the leftmost derivation in the last video, right? Then what is parse tree? A parse tree is nothing but the hierarchical representation of derivation, whatever we have used here, the derivation. For this, we have to represent the hierarchical, right? Hierarchical form. So where we can say that the tree, the hierarchical representation. The trees are having some nodes, like we are going to have the root node, we are going to have the internal node, and we are going to have the leaf nodes. So what does it mean by root node? The node which does not have any parent is called root node, right? So for example, this we have some children, but not the parent. So if you don't have the parent, that could be taken as root node. So this is the root node. And leaf node means the node which does not have any children. These are called as leaf nodes. And internal node means the node which is having both parent and children. Then it is called as internal node. So it can also called as a directed acyclic graph. Okay, at most one incoming edge. Then how to represent it? The parse tree, guys. Let me go with this. For example, if you have a derivation like this, A is x1, x2, xk, then A should be treated as a parent node and x1, x2, so on, xk will be treated as children, right? And all the terminals should be acted as a leaf node because the terminals does not have any productions. And all the non-terminals must be acted as internal nodes because the non-terminal is going to have something to substitute. The root node must be the starting symbol of the grammar because we have to start construction of the parse tree from the starting symbol. Remember this, right? So the root node of the parse tree must be the starting symbol. The leaf nodes must be the terminals. Internal nodes or interior nodes must be the non-terminals. Even sometimes it may be starting symbol also, right? And of course, even we can take the epsilon. Simply you can write A tends to epsilon. So let me go with an example by taking this. Okay. So here we have a derivation for the string AABB, right? First S is deriving AB, then A is deriving again AB, and then replace A with the A, and replace the capital small a with the A, and replace the B with BB, and replace the B with B. So we have 1, 2, 3, 4, 5, 6 productions. So then how to construct the parse tree for this? So first S is replaced with A, B. And second, the A is replaced with, the A is replaced with again AB. Right? So this A is replaced with again AB. Right? Or AA here, replaced with AA. A is replaced with AA. That's why we got AAB. Then A is replaced with small a is replaced with small a, and B again it is replaced with BB. See, we have already AA, B is replaced with BB, BB, then B is replaced with the B. That's it. This is how we got the leftmost derivation. Then same string is derived from the rightmost derivation. See here, first S is replaced with AB. The rightmost non-terminal is replaced with what? A is not changed, BB. Then you can take it BB. And the rightmost non-terminal is B, that is replaced with the small b. We got BB. And the rightmost non-terminal is A only, that is replaced with the AA. And the rightmost non-terminal is this A, that is replaced with the small a. The rightmost non-terminal is A, that is replaced with the small a. Now see, I got it. So I've constructed the parse tree for the leftmost derivation. This is a parse tree of leftmost derivation, and this is a parse tree of rightmost derivation. So even though the derivations are different, see here, the leftmost derivation is not equivalent to rightmost derivation, but the parse trees we got same. Right? Derivations are different, but we got the same parse trees. So if any string, right, for any string, if you could able to generate the two different parse trees, then we can call it as a ambiguous grammar. So that we'll discuss in the next video. Anyway, before going to that, if you have some, right, let me explain the same derivations with another string, right, the parse trees. Right, let me go with this. For example, if I'm having E tends to E plus T or T, and T tends to T star F or F, and f tends to id. If you are having like this, so I just want to generate a string like id plus id. Then first let me go with the leftmost derivation. So E derives plus we are expecting, so E plus T. What is the production we have used here? E tends to E plus T. Then we are expecting E ID, then you have to go with the T. T plus T. We cannot take directly as we don't have the E tends to ID. That's why I went with the T. Then leftmost derivation means T. We don't have star here, then you can go with the F. Because we don't have a production T tends to ID, then you can take T tends to F. Then same way id plus t, then you can go with f tends to id. Then we have the leftmost non-term is t. We are expecting only id, then you can go with id plus f because t is having f but not id. So you can take t tends to f. Whatever the replacements you are doing, guys, just go through with that. The productions must be in the grammar. Whatever the replacement we have done. id plus id. So f tends to id. This is the leftmost derivation. How to construct the parse tree for it? What is the first production we have used? E tends to E plus T. So E is deriving E plus T. The second one, E tends to T. So this E is replaced with the T. Third one, T tends to F. Fourth one, F tends to ID. Then same way, fifth one, T tends to F, F tends to ID. Whatever the productions we have used that I have represented as tree. That's we can call it as a parse tree, and it is also called as syntax tree or derivation tree. So leftmost derivation. Let me go with the rightmost derivation for the same string. So E derives E plus T. What is the production we got here? E tends to E plus T. For this T you have to substitute ID, but we don't have such production, then go for F. So E plus F. Based on the string you have to substitute the productions, guys. T tends to F. Then you can take ID after plus. So F is having ID, then you can directly substitute ID. Then you can go with F tends to ID. Now same way you can go with this T plus ID. See, now I'm going with the rightmost non-terminals here. So E tends to T. As we have only one non-terminal, that is itself the rightmost and leftmost. F tends to ID. As we are having T tends to F. Then ID plus ID. Okay. So F tends to ID. Now if you construct the same parse tree for this rightmost derivation, then you'll get the same. If you want, you try it. First E tends to E plus T. E tends to E plus T. Next one T tends to F. T tends to F. Third one F tends to ID. F tends to ID. Fourth one E tends to T. Fifth one T tends to F. F tends to ID. See, even though this is a parse tree for leftmost derivation and this is a parse tree for rightmost derivation, even though the derivations are different, see that. So this right sentential form, this is called right sentential form. See that both are different. Even though the derivations are different, but we got the same parse tree. Right? If we get the, for the same string, if we get the two different parse trees, then we can call it as a ambiguous grammar. So that we will discuss in the next video.